in the binary matrix. Given an n times n binary matrix grid, return the length of the shortest clear path in the matrix. If there is no clear path, return -1. A clear path in a binary matrix is a path from the top left to the bottom right. So from here to here. Such that all the visitor cells of the pad are 0, all the adjacent cells uh, uh, of the pad are adirectionally connected. Example, they're different in the shear and edge or corner. The length of a clear pad is the number of visited uh, cells of this path. So uh, return the length. So this is what we have to return when we copy and paste. Example 1, it shows this is this is the path from 0 to 1. It's a 2 count. So here uh, we move here 1, 2, 3. At 1, 2, we can use 3, 4, and that's the length here. And here we can't see visually, but it says we don't have a clear path, so that's it. -1. So this one starts with a 1. I think that's why it's supposed to start with a 0. So let's go ahead and do this. Yes, this one is supposed to start with a 0. So we have an n times n. We can just call it a n equals to the length of grid, and we can do m also for the column to make it easier to read, or we can just leave it as n. Not needed since it's an n times n grid. So now a binary 3. So let's check the edge cases. Edge cases if not starting 0 and hold on, let's go if grid 0 0 is not equals to 0, and if grid m, if the ending also is starting. Ending grid. If the starting are not 0, 10, -1. So grade m m minus n and n minus 1 is equals to, it's also not 0. Not equals to 0. So if this and this are not 0, for example here we can see that the starting is not, so that would not. Wait, hold on. Let's just put all. So either of these. Return -1. So now let's make a queue. Equals to DQ. And then put 0, 0, 0, 0, and then mark. So grade that grade at 0. So it will be equals to 0. That's 1. Mark first starting grade as 0. And then this will be DQ, so row, column, and path length. So while we have a queue, so now we can get into like, so let's pop, hold on, RC path length, Q dot pop, pop left, and then so once we pop it off, now the move is to easier to read, that's what I meant. So so if is equals to m, if mn equals to m minus n, and c is equals to n minus 1, return path length. And now let's make our directions. We forgot to do, but it doesn't matter. Directions be 8 directionally, so that's equals to this is different from our usual 4 directional matrix. So 0, 1, so now that's good. -1, 0, and 0, -1. So now we have horizontally, vertically ones done. So now we can go in and add the other four. So so one negative one one negative one. Now put this. Then make this one negative two. Negative one one and positive negative one. So this 1, 2, 3, 4, 5, 6, 7, 8. So that's it. For DR, DC, and directions. Let's say so. NR NC is equals to DR plus R and DC plus C. So now let's check it within boundaries. Check if within boundaries and unvisited. So now that'll be done by doing if that'll be, so if it's greater than equals to, and then and also and the thing equals to NC the N and grid and all NC is equals to 0. So now let's see. So now we can add them to the queue that append the append and NC, and we have to add one to a path button. Every time we change, add one to a dash, subtract. So append plus 1. And then let's mark it create equals to NC is equals to 1. And so that's it. That's basically it. Return -1. I'm running to see if it's going to work. Seems like there's a mistake here. So 1 0 0 1 0 1 1 1. Oops, font. There's another comma here. This is likely it. Says long answer. Oh, this is supposed to have 1 here. We're supposed to start from 1. and it's been accepted. So our time and space complexities. Time and space complexity R O of M times N. Let's submit to see if it's going to pass. And it's been able to pass all cases. And let's analyze it. It is M times N. Also M times N for space complexity. And that's it for this problem. And so the best, so this is a BFS breadth first search is